powers everything. I'm talking from a little calculator all the way up to the most powerful supercomputers on the planet. What's the common thread? You might be surprised, honestly, at just how simple the answer is.
Believe it or not, it's all just on or off. That's it. Seriously, every single photo you've ever posted, every song you've streamed, every line of code that makes the world go round, it all boils down to a gigantic collection of tiny, tiny switches that are either on or off. That's the whole secret. Okay, let's dive into this whole on or off secret. In the world of computing, this idea has a name, and you've probably heard it before. It's called a bit, and you can really think of it as the fundamental atom of our entire digital universe.
Yeah, so bit is actually just short for binary digit. And what it is, it's the absolute smallest piece of information a computer can possibly understand. There's no in between, you know? It can't be kinda on or a little bit off. It's a definite absolute state, kind of like a coin toss. It's either heads or it's tails. That's it.
So you might be thinking, okay, how does a machine actually see this? Well, it's all about electricity. We just assign the number 0 to the off state, which physically is just a low voltage signal. And then we assign the number 1 to the on state, which is a high voltage signal. It's a super simple physical language that the hardware can understand.
You know, the best analogy, the easiest way to think about this is a simple light switch, right? It only has two positions, off, which we call 0, and on, which we call 1. Now, just try to imagine not one, not 1,000, but billions of these little switches all flipping on and off together at incredible, mind-boggling speeds. That's your computer. Okay, so we have billions of switches. Big deal, right? How in the world do we get from a simple on-off switch to a machine that can do complex calculations or even create art? How do you build something that feels like intelligence out of something so, well, so basic?
Well, the answer is an invention that, and I'm not exaggerating here, changed everything. It's called the transistor. A transistor is simply the real-world physical version of our bit. It's a microscopic, tiny little switch that you can turn on or off with just a tiny zap of electricity. On is 1, off is 0.
And when I say microscopic, I really mean it. The processors in your phone or computer, the brains of the whole operation, they don't have thousands of these, or even millions. No. They have billions of transistors crammed onto a tiny chip, often smaller than your thumbnail. The scale is it's almost impossible to comprehend. But again, we come back to that same question. They're just switches, right? On, off. How can a bunch of them make a decision like, I don't know, checking if your password is correct? Well, the key here is that they don't work alone. They work together in little teams. These little teams are called logic gates. See, by arranging these transistors in very specific patterns, we can create circuits that can make super simple decisions. So for example, an AND gate. Think of it like a really strict bouncer at a club. It only says yes or outputs a 1 if both of its inputs are also 1. Then you have an OR gate, which is way more chill. It'll output a 1 if at least one of its inputs is a 1. And finally, the NOT gate is the simplest of all. It's just an inverter. It flips a 1 to a 0 or a 0 to a 1. And that's it. These are the absolute fundamental building blocks for everything a computer does.
To make this really clear, just think about an ATM. It will only give you cash if your card is valid and your PIN is correct, right? Both things have to be true. That's a perfect, real-world example of an AND gate doing its job.
All right, so we've got all these logic gates, these little decision makers. Where do they all come together to do the real heavy lifting? Well, that happens in the most critical part of any computer, the central processing unit, or as you probably know it, the CPU. The CPU, yep, it's the brain of the whole operation. And it's not magic, not at all. It's really just a master of doing incredibly simple tasks, but it does them at mind-blowing speeds. We're talking millions or even billions of times every single second. And its core job is a simple, repeating cycle. It's called the Fetch-Decode-Execute cycle. First, the CPU fetches an instruction from memory, something like add these two numbers. Easy enough. Then, it decodes that instruction to figure out what it's supposed to do. Next, it executes the command, using all those logic gates we talked about to do the actual math. And finally, it stores the result. Fetch, decode, execute, store. Over and over and over. This four-step loop is basically the constant heartbeat of your computer.
Now, if we zoom out a little bit, that whole fetch, decode, execute cycle is really just the processing part of a bigger picture. It starts with you. You provide an input, like typing 2 plus 3 into a calculator app. The CPU then processes that command, doing its little cycle, and finally, you get an output. The number 5 magically appears on your screen. Input, processing, output. This simple flow is behind absolutely everything a computer does.
So think about the journey we've just taken. We started with a single, simple switch. From there, we built a powerful processing engine. So what does all this actually enable? The answer is, well, pretty much everything in our modern world.
Just think about it for a second. The entire global banking system, all the social media platforms that connect billions of people, the complex scientific simulations that help create new medicines, your smartphone, your smart TV, your car. All of it, every last bit of it is built from that incredibly simple idea of on or off switches, just combined on a truly massive, unbelievable scale.
But this incredible progress, it comes with a catch. We are starting to hit the absolute physical limits of how small we can make these transistors. We can't shrink them forever. So to keep moving forward, to keep advancing, we're going to need a whole new approach.
And that new approach is leading us to a crazy new frontier, quantum computing. And here's the mind-bending difference. A classical bit, like we've been talking about, is either a 0 or a 1. Simple. But a quantum bit, or qubit, can be a 0, a 1, or, get this, both at the exact same time. It's a property called superposition, and it lets a quantum computer explore countless possibilities all at once. This could let us solve problems that are literally impossible for even the fastest supercomputers we have today. So, I want you to think about this for a second. We took the simplest idea imaginable, on or off, and we built our entire complex, interconnected digital world from it. The question we have to ask ourselves now is, if that's what we managed to build with a simple switch, what on earth are we going to build next?